We're continuing to solve quadratic equations, and now it's time to solve by completing the square. It's a little bit more difficult, I think, than factoring, but the benefit is any quadratic can be solved this way. So our first step is to make the leading coefficient 1. Here in A, we've got a leading coefficient of 2, and I need to get rid of that, and what I'm going to do is divide everything by 2. So I get x squared plus 2x minus 6 equals 0. Now I could have factored out a 2 like I did with the 3 up here, but this 3 made no difference in my solution. So why not just divide it and have it gone? So we divide by 2, have that lead coefficient gone. The next step is to make room for a new c. This right here is not a square trinomial, and we'll talk in a minute about what that means. But I need to move this c over and make room for a new c to make a square trinomial. X squared plus 2x, new c equals positive 6, and whatever I add here, I have to add over here as well. Third step is to find the new c and add it to both sides. The new c is b divided by 2 squared. Over here, b is 2, so that's 2 divided by 2 squared. 2 divided by 2 is 1, squared is 1. So I'm adding 1 to both sides. Now what I have here is a square trinomial. So step 4 says complete the square and solve. Really, I guess the complete the square part could probably be put up here, and all we really have left to do is solve. I have completed a square trinomial. Now it's time to solve for x. Here's why it's a square trinomial. I'm looking for two numbers that multiply to 1 and add to 2. And those numbers are 1 and 1, which means it would factor to x plus 1 times x plus 1. And that's something times itself, which really means it's x plus 1 squared. So this is a square trinomial because when I factor it, it becomes something times itself. Like 9 is a square number because 9 is 3 times 3. It's something times itself. This trinomial is something times itself. And that equals 7. To get rid of this squared, I need to do a square root on both sides, and that automatically gives me positive and negative. So x plus 1 equals plus or minus the square root of 7. And I need to move that 1 over. X equals negative 1 plus or minus the square root of 7. And that is two solutions right there. Negative 1 plus root 7, negative 1 minus root 7 are my two solutions. They are irrational, but they are real numbers. So those are the two places where this quadratic would cross the x-axis. In B, once again, I need to divide everything by the lead coefficient. You can imagine that if not everything is divisible by the lead coefficient, you're going to be dealing with fractions. It's going to be a little bit more difficult. So maybe that's a case where you might want to try a different method. But in this case, 3 goes into 3, 9, and 9. So I get x squared plus 3x plus 3 equals 0. This is not a square trinomial, so I need to move that c over. X squared plus 3x, new c, equals 0, equals negative 3, and new c. Okay, so to get the new c, I take b and divide it by 2 and square that. Now b is not divisible by 2, so in this case, I'm just going to square it as it is. I'm adding 9/4 to both sides. Now maybe you think factoring this one's going to be a little bit difficult, but it's really not going to be that bad because I made a square trinomial. I know it's a square trinomial because I made it that way. So what number times itself did we use to get 9/4? 3/2. So the trick here, once you know you've got a square binomial, half of b is what goes in here. So it's x plus 3/2. Now when I want to add these, I can do this without a calculator just fine. That negative 3, I want that to be in terms of fourths. Well, negative 3 times 4 is negative 12, so it's negative 12 fourths. Negative 12 fourths plus 9 fourths is negative 3 fourths. So I'm going to take the square root of both sides. X plus 3 halves equals plus or minus square root of negative 3 fourths. And I'm going to do two things in this step. I'm going to move this 3 halves over, and then I'm going to simplify this radical. So x equals negative 3 halves plus or minus. The square root of 4 is 2, so it's going to be over 2. The square root of negative 1 is I, so I'm going to have an I here. And the square root of 3 is an irrational number, so I'm just going to leave it as the square root of 3. So my final answer is negative 3 halves plus or minus I times the square root of 3 over 2. Now, that's a negative 3 halves plus I root 3 over 2, that's imaginary. Negative 3 halves minus I root 3 over 2, that's imaginary. So this one actually does not cross the x-axis at all. It has two imaginary roots. In the next video, we'll deal with solving by the quadratic formula.